This is my variable bench power supply build that I modeled after a YouTube video by GreatScott, and that video is titled Build Your Own Variable Lab Bench Power Supply. It is based off of a LTC3780 DC voltage regulator. It also uses a 120 volt to 120 volts AC to 12 volts DC static power supply. The meter, the volt and amp meter, its max range is up to 3 amps. So this puts out, I believe 5 amps is the max for the power supply and the voltage regulator. But like in the video by GreatScott, he mentions that small peaks of amperage won't damage it if it's temporary. Um, on my build, I incorporated a a PC cooling fan. Um, he tested out the heatsink on the voltage regulator with a pretty big amp draw, and he commented that it didn't get very hot. But this particular enclosure that I purchased had the vents on the side, so I thought, why not? I also, upon building this, I noticed the need for a load switch. Um, it's kind of a hassle to have to continually unplug your leads, whether they be these alligator clips or I have some banana clip style on the way. But it's just so much nicer to have a load switch so you don't have to worry about, one of your leads coming undone and grounding out somewhere. Now I'm gonna take the cover off and show you the inside. Okay, here is the inside of the enclosure. I obviously didn't do the best soldering job. Really, the only thing I had to solder that was very important was the outputs onto the binding posts. I just kind of threw it together, to get my layout where I wanted it. I may go back in and redo all that. Maybe add some heat shrink tubing over that just in case something were to touch it. I don't want to cause any shorts anywhere. There is the LTC3780 voltage regulator. In the video, he talks about unsoldering these multi-turn pots, and you have to be really careful because the first regulator that I purchased and I unsoldered the multi-turn pot, I think I ended up melting one of the traces. So whenever I soldered my leads on to my potentiometers that are on the face of the enclosure, I kept getting a red fault light, and nothing I did would fix it, so I had to order a new one. And I tried to I tried to keep it somewhat professional on the line in especially, and some of the smaller wires, like to the fan, I didn't worry as much about. One thing that I'm a little ashamed of is that I have not run any grounding to the enclosure itself. It has this sort of anodized coating, and I'm not really sure if I don't think it would I don't want to be the person to try it out, but I wouldn't think it would conduct if I had a short somewhere. But I really need to do that. I plan on it. Like I said, I still plan on adding a load switch. So when I do that, I may go ahead and run grounding at least to the base and maybe the cover. The front and back, we'll see. It's just a lot of extra work, but I've gone this far, so why not? Um, Really trying to think of anything else. I really want to thank GreatScott for the video. He's very thorough, very informative, shows very good pictures and videos up close, so if you're a novice you can follow along. This is really my first build like this, and I feel like for a beginner it's a really good build because everything is modular. I mean, if you can somewhat wire and you can use a drill and a jigsaw like I used for the face. I kind of did a hack job on some of it. I got a little carried away and some of the corners aren't as good, but it works. But I think it's pretty good for my first one. It's very powerful. I've melted a lot of stuff down with it just to see how powerful it is. And it's really nice to have the current limiting pot on here. I mean, it's obviously, yeah, it's great for it to be a very variable voltage, but to be able to limit your current is really the great thing about this. If you're working on some sort of intricate board or something and you don't want to draw too many amps if you have a short or something's wrong, it's really nice to have that to turn that down. So I guess now let's see it in action. I'll try to show you how powerful this is and see if I can melt a couple of resistors down. Hang tight. Alright, here is just a resistor and LED. Something simple. See if I can get it to focus here. Alright, we'll start cranking the voltage up. LED will go out. Wow, I'm really surprised it's lasted that long. And there's some smoke. Oh, the resistor's going out first. Wow. And there it goes. And it's gone. Alright, there's that. Okay, we have a 12 volt light bulb. Right now I have the voltage turned down all the way. Its minimum range is 0.8 volts. It tops out around 26 volts. I'll turn it up with the amperage limit down all the way just to show you kind of how the regulator compensates. Like I said, typically all the way up I get 26 volts, but since I have the amperage limited, it will only allow it to go to about 5.5 volts and pull 230 milliamps. So now if I bring this up, now we're going to get the full brunt. Like I said, really handy for some intricate stuff that you don't want to take the risk of burning up. I really like this setup. I plan to do a lot of prototyping, and I think this will come in really, really handy. Thanks for watching, guys.